is that I was under the impression that finals started at 8:30, just like classes started at 8:30. But no, they start at 8, or started at 8. So we should have been here at 8 o'clock. I was here, but I didn't know that finals were starting at 8 rather than 8:30, and I just started this, and I forgot to mark it. Okay, we are now recording. The light's coming on soon. Let me just go over how we're going to do this now. Do any of you have a 10 o'clock final? I didn't know finals were. Okay, you do. So if you need to leave, whatever time you need to leave, leave. I'll record. I'll keep recording as long as anyone's here. So you can go back and listen to it once it's out there on YouTube. Okay? So let's get moving for these people. And Pablo's here. And I've already returned papers, so if you still have some papers to pick up, Pablo, then get them after we finish it. Okay. And you have finished all your tests and quizzes, right? Okay, good. Okay. So we'll do this until at least 10 o'clock, when some people have to go to take a test. Didn't know, of course, the test at 10. Then, for those people who want to stay, I'll stay as late as you want to stay. Okay? I'll record it all, and anyone who has to leave can listen to the recording, just like anyone who's not here can listen to the recording. Okay. Then, after everybody's finished with the review session, no more questions, then what we'll do is turn around, and anyone who wants to take the test right then can. This room will be open. I'll be available. If you want to wait till later, some people said Wednesday. I'll be here by 8 o'clock on Wednesday morning. We can do it then. But come see me in my office. If I'm not up here in the classroom, come see me in my office. Now let me go over quickly the times when I'm not available. Okay? Basically, the rest of the day, I'm here. Okay? So you can catch me then, even if Seth did come in. Okay. I saw you. There you are right there. Okay. Okay. So anytime after we finish today, you can start your test. I'm free for the rest of the day. I'll be here at least until 6 o'clock this evening. 6 o'clock, I'm going home. So get started in time. No later than 4 o'clock. Okay, if you want to start at any time today up until 4. I'll be here till 6. Tomorrow morning, I'm giving an exam. That will be down in 205. That's a pretty big class. That's why we're not in here, because it was more than 30 students. But there are a few seats available. So if you wanted to come in the morning at 8, I didn't know, I've been telling them 8:30, but at 8, you can meet with us down there and take your test in, as long as not too many of you do. Okay? Then after that, I'm free. That's 8 till 9:50. So from 10 o'clock, I'm free. I'll be either back here or in my office, somewhere in between, from 10 until 3. At 3, at 3:15, I have a class, second mini-term class, so they actually have their last class day tomorrow. So at 3:15, we'll have our class. All we have to do is one lab and one test, okay? So that won't take them more than, I don't think more than 2.5 hours, okay? I don't know for sure, so let's just say from 5 o'clock until 8:30, I'm free. Now, don't come in at 8:30 and expect to, I'm sorry, said it wrong, till 8 in the evening. Don't come in at 8:45 and think you can do a test. Start no later than 6. So tomorrow, you can do any time after, say, 5 o'clock until 6 o'clock, come and start. I'll be here till 8. Then on Wednesday, all days, well, not quite, from 8 in the morning until 4 in the afternoon. I'll be available for you to do your test anytime then. Again, start in my office at 265, work your way up here, find out what room I'm in. I may be giving the test in one of the rooms in between or here. Okay, at 4 o'clock, I've got to go to the Birmingham East Campus, because that's where my physics students will be turning in their finals. They have a take-home final. So I'll be there from 4:30 to 6:30. So if you want to come take it then, I'll be on Birmingham East Campus, the Ethel Hall building, and I'll be there from 4:30 until 6:30. So that gives you 2 hours to take your test. So you can come there. It's room 103, Ethel Hall building. Wednesday, 4:30. I'll leave here at 4 o'clock to get over there. Thursday, all day long, okay, from 8 o'clock in the morning up until 3:15. Now, at 3:15, I'm giving a test in here. I have a feeling most of the people will want to take that early because some of them are graduating, so they will have already finished, so you can come in. But look for me here after 3 o'clock, after 3:15. And then after that, I'll be back in my office or somewhere in between. But then I'll be here till 8 o'clock at night, so start at no later than 6. Now, Friday morning, I may have told you this wrong before because I thought graduation was in the morning. It's in the afternoon. So I'm coming to this campus Friday morning, 8 o'clock, and I'll be here up until Emmett gets, let's see, and this is here. All right. Friday morning, I'll be here up until probably, let's see, are any of you graduating? I don't think you are you? I believe graduation's at 1, so I'll probably leave here at 11:30 because I think they want us there at least an hour early. So I'll leave here about 11:30. So from 8 in the morning till 11:30. After that, curtains closed. Now, if you do turn in anything, like a research paper or something like that, I hope you're not turning them in that late. And I'm not here on campus. This is anytime, Wednesday afternoon, anytime. You can slide anything you want to turn in under my door, room 265. Not this door. This is a classroom. People may be coming here. The cleaning people come in. My office door, 265, that's where you can submit things. All right, any questions? Too much, too late, but let's get going. Now, because some of you have to leave by 10, at 9:30, I want to stop reviewing the chapter 14 stuff if I haven't already finished it by then, and move to chapter 8 stuff, because I want you to have at least a half hour. Not much in chapter 8 to do. It's only one section, but I want y'all to be able to hear it too. And then we'll go back to wherever we were in chapter 14. So someone remind me when it gets to be 9:30, okay, because I don't always look at my watch very well. Okay, any questions before we get started? I've returned all your quizzes and tests to you. If you came in late and haven't gotten them, before you leave today, pick them up, okay? And one more thing. Has everyone done the student course evaluation? No, okay. Please do those. Do you know how to do them?
I think so. Didn't they send us an email?
Yeah, they sent you probably several emails. I don't know. I don't see all the student emails. But usually they send several, and most of those have links, okay? If you don't know how to receive email, hopefully that's been cleared up, but if you don't know how to get to your email, I can tell you another way to access it. Do all of you want to do it through email, or do you need to know another way? Does anyone need to know another way? What's that? I urge you to do it. It's the best feedback some areas ever get.
Are you giving us points?
What's that?
You giving us points?
That would be bribery, wouldn't it? Okay. I don't want to tarnish or threat or reward. I want you to do an honest evaluation. I think when people make you do something, you probably don't do an honest evaluation. Well, you may not, you may. But, or when you are only doing it for extra points. Please do it. We ask you to do it. I ask you to do it. I really value them. Please do the student course evaluation. Okay? Excuse me. Okay. Does everybody know how to access it or can figure it out? Okay? All right. Please do them. Please, folks. Okay. Next. We want to start on 14. Any questions before we get going? You've got all your papers back if you're here on time. Otherwise, You probably know anything you were not sure of. I'll answer any questions you have. So let's pick up and go with this. How in the world do we solve a quadratic equation like this by completing the square? Does anyone remember the rules? I change them a little bit because I think it works a little better the way I do it, but of course that's because I'm biased. Okay? Here's what I say. Separate all the terms that have x's in them. So we're going to start with 2x squared minus 4x blank, and then let's add to 1 to the other side. Okay? Got it? So that's equal to 1, okay, to blank. All right. I'm trying to do it, modify it the way the book does it too. Okay. What's wrong with this picture about completing the square? What's awkward about it? Yes, there's a leading coefficient. So factor out the leading coefficient. Okay? There's the next step. Factor out the leading coefficient. What does that leave you? No, we already factored out the 2. Okay, but we factored out the 2 out of 2x squared. What does that leave you? X. You didn't factor out an x, you factored out just a 2. X squared. Good. Minus 2x. Okay, you only factored out the 2. Okay. Blank. Okay. Close parentheses equal 1. Okay. Now, why do I have that obnoxious blank there? You were probably wondering that. Okay. Now, I'm going to go on and write down the next line because I know how it goes. Okay. Anyone remember the next rule? Complete the square. Has to do with that. With the negative 2. What do we do with it? Anyone remember? I know it's a long weekend. With no football. It was sad. Okay? Anybody? Oh, a long wet weekend. It must have washed all the memories gone. Okay? You take half of this term. Half of negative 2 is negative 1. Now, here's what I do. I go on and write down, because I know I'm completing the square, this is going to be an x, and then when I take half of that, it's going to be a minus 1. I'm going to go on and put my square there, because I know that's what's going to wind up. But I'm going to continue that, and you'll see why. When you take half of the negative 1, what do you do with it? To fill in the blank. Completing the square. You square the negative 1. And what's negative 1 squared? 1. Okay, so we do a plus 1. All right. Now, we've got a timeout here, folks. When we add it, now, when we just put a blank here, or added 1 to both sides, we didn't change the equation. We just changed the way it looked, right? But as soon as you put a plus 1 in here, you change the equation. By what? By what? Put in a plus 1. It's no longer the same equation. In fact, I've changed it by 2 because this plus 1 is multiplied by 2, isn't it? 2 times 1 is 2. So I've added 2 to this side. So what I also have to do to keep it the same equation is add 2 here. All right? See it? All right. This becomes a 3. Now here's the magical part. When we took half of this and squared it, we made this a perfect square trinomial. What's that the perfect square of? This thing right here. That's why I said you can, as soon as you start doing this, write down the x here. You take half of this, write down whatever that is, close it up, put the square, square that, add that to this side and that side. Okay? And now we have it in a completing the square mode. Now you'll see this later. Most of you are going to Math 112 at some point in your life, right? Okay? You'll see this time and time again, completing the square. You'll use that in quadratic functions, which we haven't gotten to yet, but you will. Okay? Now, what do we do at this point? We're trying to solve this equation by completing the square. We've completed the square. How do we go about solving that now? This we've done before, I know, but it was a long time ago, last week. Okay? Anyone remember how we solved that? I know. Okay. Now, I've already returned papers to everybody, so after we finish here, come get any of your papers I still have. Okay? Hopefully, I've got your research papers already, but I know you don't. Yes?
Do you put the square root?
Okay. We're going to do it ultimately. We're trying to solve this equation ultimately for the variable, right? But for now, let's settle with just solving for this. Okay? Because that's where the variable lives. So what would we do? Divide by 2. There's your first step. Divide this, both sides, by 2. Okay? Ding, ding, gone. Okay? Now we have x minus 1 squared is equal to 3/2. Now what you were thinking, okay, it's coming back, okay. What you were thinking is now you take your square roots because you have a perfect square on one side, a number on the other side. So this becomes x minus 1 is equal to the square root, but when you take a square root, it's plus or minus the square root of 3/2. Okay. Now you have one more step to do, probably a little bit of housekeeping to do. Yeah, let's keep house first, okay? Remember there were 3 rules about radicals, things we didn't want. Remember what those were? I know this was a long, long time ago, at least a couple, 3 weeks. Second? Yes, you don't like radicals in the denominator or denominators in the radical. And how do we undo that? Multiply the denominator by square root of 2. But if you multiply the denominator by square root of 2, in fact, let's just do it inside the house here. Let's multiply by 2 over 2. Okay? So this now becomes plus or minus the square root of, numerator becomes 6, denominator becomes 4. Now we can take it out of the radical, right? So we have x minus 1 is equal to plus or minus the square root of 6 over 4. Okay? Sorry. You let me get away with that. Shame on you. What's the square root of 4? 2. And it's just a 2. Don't be putting another square root down there, okay? I've seen people do that on the quiz and test. Don't. And now what do we do? To solve for x, help me folks, add 1 to both sides. So now our final answer is x is equal to 1 plus or minus the square root of 6 over 2. Now, if you don't like having the square root of 6 over 2 and not the 1, you could multiply here. Yes, okay. 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 You could multiply numerator denominator here by 2 over 2, and now you could rewrite this as 2 plus or minus the square root of 6 over 2. Another way to write it is no worse than what we had here, where we had 1 plus or minus the square root of 6 over 2. But, here's a big but, not me, but, oh, never mind. Okay? But I don't know if I've told you this or not. The final exam has 30 multiple choice questions. That's the beginning of the final exam, 30 multiple choice questions. So if the multiple choice question didn't have a 1 plus or minus square root of 6 over 2, but did have this, that's the same answer. That's the one you mark as right, okay? You could have had, oh, we already did that, 1 plus or minus the square root of 6 over 2. So that's why you need to recognize these different forms. You could have been lots of different forms, so you have to figure out how to get the form that you're going for, okay, that they're looking for. So the first 30 questions are multiple choice, 2 points each. That's 60 points. The next 8 questions are 5 points each, and that gives you the additional 40 points, and that gives you a total of 100. Okay? So that's what to expect on the final. Those 8 questions at the end are more like the ones we've done on our tests and quizzes. You work them out and give the answer. But on this time, work them out on the piece of paper and show your work, because I can give partial credit if you show some type of work and you're heading in the right direction. If all you have is a wrong answer, all I've got to grade is a wrong answer. Okay, thank you. Okay, so please, folks, be ready for that. Be ready for 30 multiple choice questions and 8, worked out solutions. Okay, any questions? That's our solution. Let's see how they did it. And I'll try to speed this along because I'm taking way too long doing this. But y'all are not answering very well, so I don't know if it's that you don't know this. Okay, first thing they did was add 1 to both sides, just like we did, but they didn't leave the blank. You should have, okay? And the reason is so you can, oh boy, what a weird way of doing this. This is also correct. I would never have suggested this for you. But what they chose to do, in order not to have a leading coefficient of 2, they multiplied both sides of the equation by 1/2, which is legal. And if you like this, you certainly can do it, okay? That gave you x squared minus 2x is equal to 1/2, okay? Then the next thing they're going to do is complete the square. See, they still didn't put the blank there, but if they had put the blank, then they could have taken half of this, minus 1, square it, and that becomes a plus 1, okay? But if you add 1 to this side, you add 1 to that side. See, they don't have the 2 over here anymore, so that's just simply adding 1 to both sides, okay? Any questions? Okay. This now is a perfect square, and that would be x minus 1 squared is equal to 3/2, because 1/2 plus 2/2 is 3/2. So they wound up with exactly the same thing we did. It's just they got it a slightly different way. If you like their way better than my way, go their way. It's fine. It's perfectly correct. Now you take square root of both sides, and that gives you square root of a perfect square is just the number. So that, they left off the plus or minus, didn't they? Shouldn't have done that. You should always put that plus or minus on the number side. Okay? Now they did. I don't know why they didn't to begin with, but this is, when you take the square root of a perfect square, you just get the entity. So x minus 1 is equal to plus or minus the square root of 3/2. And let me get Sierra here. Well, she's already here, but let me mark her here. Okay, has anyone else come in that I wasn't watching? Okay. Yeah, I got you. Okay. All right. And then the next step, of course, is to add 1 to both sides. Well, no. Then they separate the square root of 3 from the square root of 2, which is perfectly legal. We didn't do it this way, but they did. Next thing they're going to do is multiply by square root of 2 times square root of 2. They don't show it, but, well, they show it over there. And that gives you square root of 6 over 2, plus or minus. And now they're going to add 1, which is, okay, they're going to do it that way. This is perfectly legal too. Here they're splitting the plus or the minus. Here they have x minus 1 is equal to plus or minus square root of 6 over 2. So now they write that as x minus 1 is equal to square root of 6 over 2, and x minus 1 is equal to negative square root of 6 over 2. Again, perfectly legal to do. If you like this better, go for it. Now they're going to add 1 to both sides of both of those, and you get x equal 1 plus root 6 over 2, and x equal 1 minus root 6 over 2. And again, these are perfectly correct answers, okay? But they're going to go one more step and make the 1 2 over 2 in both cases, and then those are both perfectly correct answers, but really a weird way to write them. Then when you write them this way, putting 2 plus square root of 6 over 2 and 2 minus square root of 6 over 2, that's the way they put their final answer. I would have left it 2 plus or minus the square root of 6 over 2. So expect any of these things on those multiple choice parts. Your final exam, the first 30 questions are multiple choice. So if you don't get exactly their answer, manipulate your answers until you get one of the answers they've done. If you don't get any of them, go back and recheck your problem, okay? You may have done something wrong, okay? But that's how they leave their answers. So the solutions are 2 plus square root of 6 over 2 and 2 minus square root of 6 over 2. I like it 2 plus or minus the square root of 6 over 2. It's a lot less writing. All right, any questions? This is check your understanding 1 and then 5 practice problems. I suggest you do them all. Let me move on and try to pick up the pace a little bit. Any questions so far? Anybody? Okay, let's do 3A. Now the first of this is going to be long and tedious. I'm going to try to move it along, okay? It's sort of take my word for it, okay? Quadratic equations, module 14, section 14.3 is solving quadratic equations using the quadratic formula. The easy way to go. Once you do this, you don't have to go back and do completing the squares again. So this is really an easy way. Later you'll have to do it again. Don't worry, you're going to have to do completing the squares throughout your mathematical life. But for now, once you learn this, you don't have to do it again to solve quadratic equations. So we're going to solve quadratic equations using the quadratic formula. Any quadratic equation can be solved by completing the square. Any one. Now, some quadratic equations can't be solved by factoring. They just will not factor. But they can be solved by completing the square. Okay? Applying this method to the standard form of a quadratic equation, that's the one without any numbers in it, all letters, ax squared plus bx plus c is equal to 0. That's standard form, as long as a is not equal to 0. And that's really important here. Here's your answer. X is equal to, this is your answer, minus b plus or minus the square root of b squared minus 4ac all over 2a. Now, if we were having a test in here on this, I'd say write this down and bring it with you on the test. Since the final exam does not allow a formula equation sheet, write this down. Work enough problems until this gets ingrained in your head. This is the quadratic form, frequently written as x equal minus b plus or minus the square root of b squared minus 4ac all divided by 2a. And what's this a, b, and c? Anybody? These are your constants up here in your quadratic equation. Right there in front of you. Okay? Now, what they're going to do now is show you how they got it. And I know y'all want to know that, don't you? Oh, no, they're not going to show it to you. They show it to you in the book. Okay? I'll leave it like that. You can look in the book and see how they got it. Right now, all you have to do is remember it. Okay? I guess I'll skip the first example and go right to the focus. All right. How would you solve this? Anyone want to try factoring? Knock yourself out. Okay? actually it may factor. But we're going to do it using the quadratic formula. Okay? Now that I looked at it, I think it would factor. But we're going to use the quadratic formula. What do we need to do first? Anybody? Hint. You need to identify your A. What's your A? 2. Your B. Second. -3. Keep the sign with it. C. 1. Perfect. Can you write down your answer right now? X equal. Give me that formula first. I want you to say it so you get it in your head. What's that formula? Minus B plus or minus the square root of B squared minus 4AC. All divided by 2A. Okay? Now, at this point, you just plug it in, just like the lady. Okay? So X is equal to, what is minus B? Second? +3. Plus or minus the square root of, what's B squared? 9. Minus 4, what's A? Times 2, and what's 1? Okay? Over 2 times what? 2. Okay? That will be 3 plus or minus the square root of 9. Now here's what I do on this part, folks. First thing I do is count my negative signs. This -4 is always a negative sign. Okay? But you don't have any more, so you just have one negative sign. If you have 1 or 3 negative signs, this stays a negative. If you have an even number of negative signs, which would be 2, then that becomes a plus. We keep it a minus. Okay? And what's 4 times 2? 8 over, and what's 2 times 2? 4. Okay? Well, we can do what's under the square root. That's 3. I say 3 and write 2. I don't know what's wrong. Plus or minus, what's 9 minus 8? 1. What's the square root of 1? 1 over 4. This gives you 2 answers. Let's do the plus first. What do you get when you use the plus? Second? What do you get? You may have said it. I can't hear well. 4 over 4 or 2 over 4. Okay? And 4 over 4 is 1 or, and 2 over 4 is 1/2. Now, if you wind up with rational answers like that, that means you could have factored this. And like I said, yep. As soon as I looked at it, I said, yep, you could have factored that. That would have factored as 2x times x and minus times minus, 1 times 1. Check that, it works. That'd be 2x minus 1 equals 0, or x minus, x minus 1 equals 0. And if you add 1 to both sides, you get 2x is equal to 1, x equal 1/2. There it is. Add 1 to both sides, you get x equal 1. There it is. So you could have done it either way. It would have been easier probably factoring it, but they wanted us to practice with the quadratic formula. You see how it works? And as soon as you get it down, if you wind up with a perfect square here, take the square root of it. If you don't wind up with a perfect square there, leave it in radical form. Okay? You got your answer. But if you do have a perfect square here, and we did, 9 minus 8 is 1. 1's a perfect square. That's 3 plus or minus 1 divided by 4. All right. Any questions? You see it? Okay. All right. Let's watch how they did it and see if they do it any differently. They may have just changed a step or two. They wrote it down again. That was so clever. Then they put in a minus 3, which is fine. Okay? And that gave them same thing we got. And 3 plus or minus square root of 1 over 4. 3 plus or minus 1 over 4. And that would be 3 plus 1 over 4 or 3 minus 1 over 4. They took an extra step there. That would be 4 over 4, which is 1, and 2 over 4, which is 1/2. Exactly like we got. Make sense? Any questions? Okay, let's do the B part. All right, let's do the B part. Uh-oh, what do we do with that? Absolutely, you got to get it in standard form. So as she said, subtract 8x from both sides. But you also add 5 to both sides. Okay? And that gives you 2x squared minus 8x plus 5 is equal to 0. Standard form. Now what do you do? Help me, folks. Okay. Yes, find your A, B, and C. What's your A? What's your B? -8. What's your C? 5. Okay? So what do we do with that? Write down your answer. Plug it in. X equal? Excuse me, folks. Excuse me. 8 plus or minus the square root of? Say again? 8 squared? 64. Minus 4 times 2 times 5. Okay? All over 2 times 2. Perfect. And this is 8 plus or minus the square root of 64. Again, count your minus signs. They're exactly 1, so that's going to be a minus. And then what in the world is, what's that? 40. Perfect. Okay? Divided by 4. So this will be 8 plus or minus the square root of 24 divided by 4. Now, remember what were the 3 rules for radicals? What do we not want? I'll give you 2 that don't apply here. You don't want any radicals in the denominator? We don't have any radicals in the denominator. We don't want any denominators in your radical? We don't have any denominators in our radical. What do we have? You have a perfect square hiding in there, don't you? Okay, that would be 8 plus or minus. What perfect square do you know in 24? What perfect square do you see in 24? A little louder? Anybody? Any perfect squares in 24? Not that hard. What are your perfect squares? We don't ever count 1. It's always there. 1 squared is 1. Don't count it. 2 squared is? 2 squared is? 4. Is 4 in 24? Yes, it is. So it's the square root of 4. And what's left? 6. Okay. Pulling teeth here. Over 4. Okay? That'd be 8 plus or minus. What's square root of 4? 2. Don't put a square root on that. Okay? It's 2. You took it out of the square root. Times root 6 divided by 4. Now what do you notice about that? you noticed about that? You can divide numerator and denominator by 2. So factor out a 2 in your numerator, and what do you have left? What do you have left? Did someone say 4? Plus or minus? Root 6. Okay? Divided by 2 times 2. That's 4, right? Factor out the 2's. Here's your answer. 4 plus or minus root 6 divided by 2. Okay? There's your answer. Or 4 plus root 6 over 2, comma 4 minus root 6 over 2. Either one of those will be answers. Remember, you do have multiple choice coming up on your final exam, so be sure you know how to manipulate it to get into whatever form the answer is given there. Make sense? All right. Let's see how they did it. Here we go. First thing they did, this was not in standard form. You have to get it in standard form before you can apply the quadratic formula. So subtract 8x from both sides, add 5 to both sides, and have 0 on the other side. Okay? Then they don't do it, but you identify your A, B, and C. Minus a B is minus or minus 8. That's positive 8, plus or minus the square root of negative 8 squared, which is 64, okay? And then minus 4 times 2 times 5 over 2 times 2. That would be positive 8 plus or minus the square root of 64 minus 40 over 4, just the same that we got. And that would be 8 plus or minus root 24 over 4. Okay? Then they simplified the radical, pulling out the perfect square of 4, 2, and that gave them that, but now they can simplify that answer by dividing out a 2 from numerator and denominator, giving 4 plus or minus root 6 over 2. Make sense? Yay or nay? All right, good deal. Those are your solutions. They can write those or not, I don't care. Okay, that's the end. We're just doing the what they have on the slide set. I'm not doing the others. If you need the others done, stop me and tell me, and we'll do some of the others. I'm just doing what's on the slide set here. Whoops. All right. We're still in Module 14, quadratic equations, still solving quadratic equations by using the quadratic formula. Now we're going to solve quadratic equations using the quadratic formula. I thought we just did that. Oh, we did do that. Why did it not change? Okay, because I didn't change it, I think. Okay, 14.4a. Sorry, there wasn't a 3b. Sorry, this takes a little bit longer. Okay, here we go. From current slide. We're still in Module 14, quadratic equations. Now we're in 14.4, applications. We love them, of quadratic equations. Solve some application problems. Okay, let's do these as thoroughly as we can, but as quickly as we can. A kicker punts a football at an angle of 60 degrees with the ground. Okay? That's from horizontal to around 60. Assuming no air resistance, the height h in feet of the punted football, x feet from where it was kicked, can be given by h is equal to minus 0.0065 x squared plus 1.73x plus 4. Now, you don't need to know how they got that formula. I can't even tell you how they got that formula, but it's right, okay? So the question is, how far is the football from the kicker when the height of the football is 70 feet? Okay? What are we looking for in this problem? How far is the football from the kicker? What answers that question? The what? No, what did you say? How far is it from it? It's basically given to you right up there. Assuming no air resistance, the height h, the height is h in feet of the punted football x feet from where it was kicked. So x represents. So what we're looking for here, how far is the football from where it was, when the height is that, how far? That's going to be x. So we're looking for x in this problem. There it is. Oh, okay. Now, when the height is, and what's the height? 70 feet, but what does that represent here? H, exactly, where the height, h in feet. Okay, we got it, folks. Okay? We put in the 70. Let me get my pen back. Okay, put in 70 for the h. It's a direct substitution. Is equal to negative 0.0065 x squared plus 1.73 x plus 4. Okay? Yay. What we're looking for is x. How in the world do we get it? How in the world do we get it? Okay, you certainly could do that. You could subtract 70 from both sides of the equation. And that would give you your new equation. I'm going to swap sides on it now. Is that okay? Negative 0.0065 x squared plus 1.73x, and then what? Minus what? 66 is equal to 0, because this goes to 0. All right, there's a quadratic equation. Any of you want to factor it? I think not. Okay? I don't. Okay? Anyone want to try completing the square? Please say no. Okay? I don't. Okay? So what do we use? Quadratic formula. And what's the first thing we do? And what's your A? Yeah, negative 0.0065. What's your B? 1.73. And what's your C? C is equal to negative 66. Okay. So, what do you get? What does it tell you? X is equal to negative 1.73 plus or minus the square root of say again?
2.99.
Okay, 1.73 squared, right? B squared, right? Then what? Minus 4 times, sounds what? Which is negative 0.0065 times negative 66. I'm running out of room. Okay, all over 2 times negative 0.0065. Oh, isn't this a joyous problem? Okay. Now, okay, if I haven't said this already, let me make sure I say it loud and clear now. Please bring a calculator to your test, okay? A calculator you know how to operate, you know the syntax, you know how to enter these things, because can you do this one without a calculator? Maybe, but it's going to take you about 5 or 10 times longer to do it with without a calculator than with one. Please bring your calculators. Calculators you know how to use, okay? Any questions? Please bring your calculator. I wouldn't attempt this problem without a calculator. X equal, I can do the first part, negative 1.73, plus or minus. Someone with a calculator tell me what 1.73 squared is. A little louder? Say again?
2.99.
2.99?
Yeah. 2.9 if you want to add that.
2.9? Okay. Now, next thing I do is count my number of negative signs. 1, 2, 3. What does the sign turn out being? That's an odd number of negative signs. This is negative. If that was even, positive. Okay? So that would be a minus. Okay, and again, someone with a calculator. 4 times, once you get the sign down, don't worry about the other signs. 4 times 0.0065 times 66. 1.41. 7 what? 712. Okay.
No. 1.716.
Okay, wait one. Okay. 1.716. Okay, 1.716. Okay. All over negative 0.013. Right? You get that or not? 2 times 0.0065. Is that not right? Okay, good. All right. So this will be minus 1.73 plus or minus the square root of, and do that subtraction, and I believe you get a 1.28 or no, 21. Wait. Yeah. 28. No, I think it's 27. Yeah, you're right. 27. What? Okay. Let's just leave it as, yeah, you said 5? No. Say again? 6-1? Yeah. Say again? I can't hear. 6-9. Let's just leave it 6. Or make it 7. That'll be rounded off better. Okay? All over negative 0.013. It's messy, yes. Okay? I think you can do this with your calculator just like it reads. You're going to have 2 answers, right? The first is going to be negative 1.73 plus the square root of 1.277 divided by negative 0.13. That's going to give you a negative answer. No? A positive answer. What would that be? Okay, wait, say that again. 1.1 what 0? 30. That would be feet. Now, that doesn't sound like you kicked it very far. Okay? What's the other one? When you have, huh? Okay. Negative 1.73 minus the square root of 1.277 divided by negative 0.013. Anyone do that one? Now, somehow somebody got the wrong answer there, I think.
I was giving you the square.
Oh, you were giving me the square. Oh, sorry. I thought that can't possibly be true. Okay, sorry about that. Okay. Let's just cut to the chase and just do what they did in the book. That's either an x equal about 46.2 feet or 220 feet. Really? All right. Now, okay, if you divide 3 into this, you get something on the order of about 15 yards. It's not a very good kick, is it? Divide 3 into that, and you get something on the order of 70 yards. Sign him up, okay? Both of these are pretty unrealistic answers, okay? This is awfully short for a punter. I don't think Nick would like him. And that one, I think he'd sign him in a second. You know, if he can kick 70-some yards, this is sort of unreasonable. When the football is 70 feet high, it is either, oh, I'm sorry, that is, sign this baby up, okay? Yeah. Here's what you got, okay? It's either, it's on its way up, it's there, and on its way down, it's here. So that's 220 feet, and it hasn't even got close to the ground yet. It's still 70 feet high. So that means when it hits the ground, that's almost the whole football field, isn't it? I don't think this is very realistic. If you got that punter, keep him, okay? Don't let him graduate, okay? Okay. Hang on to him, okay? Not a very reasonable problem, okay? But it gave you the general idea. You hit 70 feet on the way up, and you hit 70 feet on the way down. Okay, good deal. All right. Let's see how they did it. I'll erase what I did. Is it? Oh, my word. Okay, you think you have a general idea of how to solve quadratic functions. Let's now move to 8.2, okay? Let me just take a look and see if there's anything else here in chapter 4. Oh, they do have something on complex numbers. Okay, does anyone know what the imaginary number is? Here are the things you need to know about complex numbers. Okay? I is equal to the square root of -1. You can't do it. Not in the real number system, but in the complex number system, I is the square root of -1. Okay? That means that I squared is equal to -1. So if you know these two facts about complex numbers, you have most of the complex numbers down. Okay? Now, let me give you some examples. Someone give me a number, any number in the world. Help me. 2. Plus or minus? Well, let's do plus. Another number. 3. I. That is a number written in standard form, a complex number written in standard form. It has a real part and an imaginary part. Okay? Now, what if we're adding that to another number? Give me a sign, plus or minus. Minus, give me another number, plus another number, any number. 7. Plus or minus? Minus, another number. 5. I. If you're adding these two, you add the real parts, -5. Add the imaginary parts, -2i. That's how you add complex numbers. Okay? What if we're subtracting complex numbers? 2 plus 3i minus a -7 minus 5i. How do you do that? Same way you add binomials. 2 plus 3i minus a minus would be plus 7, and minus a minus would be plus 5i. And then you combine like terms, and that would be, anybody? 9 plus 8i. Very good. All right. Let's take that 2 plus 3i and multiply it by -7 minus 5i. You gave me the number, so you won't write. Okay? How do you think you multiply these? Boiling it, exactly. Okay? 2 times negative 7 is negative 14. 2 times negative 5i would be negative 10i. 3i times negative 7 would be negative 21i. And then the last, negative 15i squared. Perfect. Okay? Now combine like terms. Well, I want to do, well, let's do it. Minus 14. Combine these like terms. That will give you minus 31i minus 15. But what is I squared? This is the one thing you had to remember. Negative 1. Well, guess what that gives you? Negative 14 minus 31i plus 15. That would be 1 minus 31i. There's your answer. You see? Always that last term, the I squared, is going to become a real number. Because I squared is negative 1. Then you add that, combine it. First number, your real part. Combine your imaginary parts. Okay? That's how you multiply complex numbers. Let's divide them. Yuck. Okay, I'm going to have to clear my screen here. Okay. What was it again? 2 plus 3i. You want to keep the other one? It's up to you. You want to keep it? What was it? Negative 7 minus 5i? Okay, how do you think you divide those things? How did we divide radical numbers? You remember that? You better remember it. We did it, and it's going to be on the test. How do we divide radical numbers? You don't like dividing by by irrational number. We don't like dividing by a complex number. We want to divide by real numbers. How do we do it? Multiply by the conjugate. Negative 7 plus 5i. Do you remember that? We didn't do complex conjugates, but we did the other. So you multiply this. Negative 7 plus 5i. Okay? And then we do just like we did before. What did that come up being? 1? No, it was a different problem. Sorry. It's minus 14 plus 10i minus 21i. Whoops. Say again. What? No, plus 15 in this case. You're multiplying by the conjugate, which is a plus. So it's plus 15i squared. Okay? That's your numerator, your denominator. Whoa, now this is where the magic happens. When you do these two, you get 49, right? Minus 7 times minus 7. When you do the outer two, you get minus 35i, right? When you do the inner two, what do you get? Help me. The inner two. Plus 35i. Do you see? And then you get minus 25i squared. But what's I squared? Negative 1. These two add to 0. They always do when you multiply by the conjugate. Just like the irrational part did when you multiplied by the conjugate there. Okay? So this gives us minus 14 minus 11i minus 15, right? Because I squared is minus 1. Okay, that's divided by 49 minus 25 times what? What's I squared? Negative 1. Okay, so this gives us minus 29 minus 11i over 49 plus 25, which is 74. Now, I'll tell you now, I don't think they'll ever give you the answer in that form. They'll always change it to minus 29 over 74. That's the real part, minus 11 over 74I. That's the imaginary part. Y'all gave me the number, that's why it came up such weird fractions. That's how they want the answers to look. Real plus imaginary. Okay? So you see how to divide irrational numbers. Complex numbers. Okay. I think that's all we need to do there. Now let's quickly go back to 8.2. I don't think I have slide set on it because they didn't tell me they had this. So 8.2, introductions to functions. Okay? Let me just make sure I didn't, by some chance, put 8 in here. I don't think I did. Nope. I had it in. Oh, no, I did. Look at that. They originally had me do it, and I put it in there. I don't remember if I put them on your blackboard or not. Okay? And if you have to leave, go on and do it. I know it's 9:48. You got a little bit of time. But let's do as much as we can here. And if you have to leave, I'll still have this on the YouTube. Linear functions and inequalities of two variables. Okay? Introduction to functions. Okay? Evaluate a function. In mathematics and its applications, there are many times when it's necessary to investigate a relationship between two quantities. Okay? Here is a financial application. Consider a person who is planning to finance the purchase of a car. We're doing this right now. Okay? Oh, good deal. Thank you. Okay. And then come by any time between now and Friday morning and do your test. Okay. If the current interest rate for a 5-year loan is 5%, I don't think it is, but it might be, the equation that describes the relationship between the amount that is borrowed, B, and the monthly payment, P, would be this. P would be 0. And this is a monthly payment. Now, I'll tell you how they got it. This is the annual, so do 5.05 divided by 12. See what you get. 0.05 divided by 12. What you get?
0.004.
Oh, that's not how they did it. Okay, 0.004. I thought it would. Okay, what this must be then is what they call the effective rate. It doesn't matter; they're giving it to you. Okay, 0.018871 B. Now, what that is, I don't know if you've noticed on your bills when they say APR, annualized percentage rate. That's what this is, the annualized percentage rate. We're not going to go into how they got it. That's not important for this. But here's the thing. If you borrow B amount, every month you got to pay P amount, right? Okay? And this is annualized over 5 years, okay? So whatever if you borrowed that amount. Now, if the next month you paid whatever that was, then the amount that you owed, no, they've already annualized it. You're going to pay this amount every month for those 5 times 12 is 60 months. That's how much you're going to pay. For each amount the purchaser may borrow B, there's a certain monthly payment P. Okay? That relationship between the amount borrowed and the payment can be recorded as a set of ordered pairs. Okay? How much you want your car to be worth? You want a new car, used car, whatever. You decide what you're really wanting to borrow. Maybe you got enough to make a down payment and you can cut this stuff. So you decide how much you want to borrow, and then that determines how much you're going to be paying every month. Buy a more expensive car, you're going to borrow more, pay more. Buy a cheaper car, borrow less, pay less. But it's still going to have a direct relationship. Okay? Amount you borrowed, that's called the independent variable. That determines. Because once you determine that, you determine what your payment is. Right? Okay. Now, for each monthly amount then there will be a certain payment. The relationship between that is the ordered pairs, where the first is in the coordinate is the amount borrowed, and the second is the amount of the monthly payment. So you have an ordered pair. 1,000, this would be $189. That's up there, $188.71, okay? Or something like that. That would be how much you would pay. I probably said that wrong. $10 whatever. But you see, whatever your borrow amount is going to set you a payment, okay? A relationship between two quantities is not always given by an equation. It could be given in a table. This table describes the grading scale, just like ours, isn't it? 90 to 100 A, 80 to 89 is B, 70 to 79 is a C, 60 to 69 is a D. Don't go there, or 0 to 59 is an F, okay? For each score, the table assigns one and only one letter grade, okay? So therefore, if you get an 84, you're going to get a B, okay? So that's how this works. For any given score, the independent variable, you're going to get a certain grade, dependent variable, okay? So here's the definition of a function. Now you still got test 4 to take. When are you going to do that? Okay, did you already turn in quiz 4? You did turn it in. Okay, good deal. Okay. So here's what a function is. A function is a set of ordered pairs in which no two ordered pairs have the same first coordinate. Okay? They do not. The domain is a set of first coordinates or in the ordered pairs, and the range is a set of the second coordinates. Okay? So here's some examples. This is another example of a function. A set of ordered pairs. 1, 2, 2, 4, 3, 6, and 4, 8. Now it doesn't have to be a pattern. This does have a pattern. But it doesn't have to. The first one is double what the second is. The second is double what the first is. Okay? The domain of this is 1, 2, 3, and 4. Okay? It is a function because the first coordinate is never repeated. So that is a function. The range is the set 2, 4, 6, and 8. Right there. Now notice sets are given in these squirrely things which they call braces. Ordered pairs are given inside parentheses. Okay? The order matters in an ordered pair, by the way. Okay? In this one, here's a set of ordered pairs, -1, 0, 0, 1, 1, 0, 2, 0, and 3, 0. Is that a function? Yay or nay? Yes, it is, because the first never repeats. The second repeats every time. That's okay. The first never repeats. Domain is -1, 0, 1, 2, 3. This is what range? 0. That's all you ever get in the second function. That, by the way, is called the constant function. It would be 0 no matter what you put in for the domain. The range is always 0. Constant function. Okay? At least for those values in the domain. Does this make sense so far? All right. Now consider a set of ordered pairs. 1, 2, 4, 5, 7, 8, and 4, 6. Is that a function? No, why not? 4 shows up twice with different answers on this. Not a function. Here's one way I think of it. This is sort of a dumb way to point out, but it's the one way I don't know that I'll be bothering those people in the next classroom. Let's say you're in the bookstore and you're buying a bag of chips, okay? And the person in front of you is also buying this identical bag of chips, okay? And he goes through and they charge him $1.19 for that bag of chips. And then you go through and they charge you $1.29 for that identical bag of chips. Are you a happy camper? No, because for any given input, that's the first one, you can't have two different outputs. So if you had a 4 going in and it came out a 5 the first time and a 6 the next time, not a function. Because for the same input, you got two different outputs. Okay? So therefore, that is called a relation, but not a function. A relation is any set of ordered pairs, whether it repeats or not. The function is a special type of relation, and the concepts of domain and range apply to relations as well as functions, but they don't have that same rule that for any given input, you can't have but one output. For the grading scale function, the domain is a set of all possible scores, 1 through 100. The range is all possible grades, A, B, C, D, and F. That, by the way, yeah, it would still be a function, because the domain, only one of those ever shows up, and each one has one and only one answer. These would all be F's. These would all be A's, okay? So for any given input, there's only one output. For a graph, the domain is represented on the horizontal axis, and the range, or the dependent variable, is on the vertical axis. Now, we often call them X, Y axis. I like to call them horizontal and vertical. The square function, in which pairs of real numbers with a square, can be defined by an equation. Here's another way to express a function. Y is equal to x squared. Give me an x. 1. What's 1 squared? 1. Only one answer. Okay? Give me another x. 10. 10 squared is 100. Only one answer. How about a negative 1 for x? 1. That's perfectly fine, because negative 1 only has one answer. Both 1 and minus 1 both have the same answer. No sweat there. But any given x can only have one answer. So that indeed is a function. That equation states for a given value of x in the domain, whatever value you have, the corresponding value for y is in the range is the square of x. So what is the domain of that function? No, all real numbers. You can put any number you want to in there. Perfectly fine. What's the range of that function, though? 0 to infinity. Perfect, because only non-negative values. Because you can never have a negative value once you square a number. So in this instance, when x equals 6, y is equal to 36. If x equals negative 7, y is equal to 49. One and only one answer for any given x. Because the value of y depends on the value of x, y is called the dependent variable, x is called the independent variable. You get to choose any number. That's why I say, give me an x. Any number you want to, that'll make that work. Okay? A function can be thought of as a rule that pairs one number with another number. If x represents the first coordinate, then the second coordinate is x squared, then x squared, that would be the same one we just had. A function cannot have two ordered pairs with different second coordinates in the same first. That's what we've already said. However, a function may contain ordered pairs with the same second coordinate, even though it has different firsts. That's perfectly fine. Negative 3, 9, and negative 3 minus 9, that would not work. Okay. You can't have two different firsts, same first and different seconds, but you can have different firsts and same second. That's perfectly okay. Second coordinates are the same, first coordinates are different. Yeah, okay, that's perfectly okay. I want to make sure they said it right. The double function is just one that pairs a number with twice the number. That's the one we had earlier. 1, 2, 2, 4, 3, 6, 4, 8. Okay? X represents the first coordinate, second coordinate is 2x, whatever you've doubled. Now, remember we said this goes on the horizontal axis, that goes on the vertical axis. What usually goes on the vertical axis? Y. Y is equal to the function of x. That's what we're going to say. The phrase y is a function of x, that's the most important thing for you to remember when you're dealing with functions. The same phrase with different variables used to describe any function. So that leads us to function notation, and that's just saying f of x. You've probably seen that before. That's what it means. The symbol f of x is read the value of f at x, or f of x. Okay, we always say f of x. But this is your y, x is your x, f of x is the y. Remember that. That's the y value. F of x or g of x or q of t or whatever is always the vertical value. The symbol f of x is the value of the function and represents, and so if you do a substitution, yeah, we're going to do evaluating the function next. So let's do that real quickly. Evaluate g of t equal 3t squared minus 5t plus 1 when t is equal to 2. I'm going to write this out for you so you see how you do this. I'm going to need to get my pen set up. Okay, so what we're doing is g of 2. When t is equal to, minus 2. When t is equal to minus 2, guess what we do? 3 times, you plug it in. What would that be? Negative 2 squared minus 5 times negative 2 plus 1. And what's negative 2 squared? 4. And minus 5 times minus 2? What's that again? Plus 10 plus 1, and this would be 12 plus 11 equal 23. Perfect. For any given input, you get one and only one output. That's a function. Does it make sense? Okay. That's your y value when negative 2 is your t value. Here, t is on the horizontal axis. Whatever is going to be on the vertical axis. Okay? All right. That's how we did it. Let's see how they did it. Same way. Exactly the same. You see? Make sense? Functions aren't too bad. Don't let them scare you. Just a different way of talking about it. Okay? 23. When t is equal to negative 2, the value of the function is 23. Sorry. Sorry. Okay. How much longer y'all got? Long as it takes? You okay? Keep going? Okay. Huh? No? Why not? Huh? Yeah, you can go anytime you want to, but I just didn't want to keep y'all here if any of you had to go. Okay. When a function is represented by an equation, the domain of the function is all real numbers for which the value of that equation, now this is important, so go back and listen to it, for which that value of the function is a real number. For instance, this one, f of x equals x squared, like we said, any x you want to put in there. Positive, negative, fraction, decimal, rational, irrational, you can square it, and it'll give you an answer. Okay? All real numbers, because it's squared. Okay? So this is how you say the domain is set of all real numbers, set of all x's, such that x is between negative infinity and positive infinity. I mean, that covers them all, doesn't it? Okay. Now, how about this one, though? Can you plug any number in the world in here for x? There's one you can. You have to watch for three things here. You cannot plug in 2. Why? Make sure the denominator is 0. You can never divide by 0. So it's a set of all real numbers except x cannot equal 2, ever. So it's up from negative infinity to 2, and from 2 to positive infinity, but you can't have 2. Okay? So here's the easy way to say it. Set of all x's such that x is not equal to 2. Well, x equal to makes that undefined. So any polynomial you have there, that's going to be fine. All real numbers. If you have a rational expression, then whatever that denominator, remember where we set that? The denominator cannot equal 0, then whatever. If that was a quadratic, factor it out and see what values can't happen there, then those would be the ones you put can equal. Okay. Now, the second thing you have to watch out for, you can't take the square root of a negative number. So if you had a whoa, that's all, folks, of that one. Okay. I'm surprised they didn't do, 8 came before 13. 13 is where we did radical numbers, so you don't have to worry about that. But you can't take square root of negative numbers. Okay. All right. Okay. Now, there's 2 more sections in 8. You want to go on and do those 2, or are you happy with it so far? Going to do those? All right. They're pretty short, I think. They're all usually pretty short. Okay, we'll go from current slide. Module 8 is still linear functions and inequalities of 2 variables. 8.2, the one we're doing is introduction to functions. And now we're going to do graphing functions. All right, we love it, don't we? The graph of a function is a graph of all the ordered pairs of that function. Graphing a function is similar to graphing an equation of 2 variables. It's just where your f of x is equal to your y. That's it. Remember that. Plot the corresponding ordered pairs, then connect the points to do the graph. For every ordered pair x, y, graph of function y is equal to f of x. That's what you remember about functions. Y is your f of x. So that's what we do. So let's grab down. Does anyone recognize what that stands for? These bars here? Absolute value. You're absolutely right. Absolutely right. Absolutely right. Good. Okay. So begin by plotting the ordered pairs x, y, but what your y is your f of x. So pick some numbers. They gave you a bunch to go from, -5, -4, -3, -2, -1, 0, and 1. They knew what to do. So let's plot those, and then we'll estimate the domain and range once we see what the graph looks like. So when x equals -5, what does f of x equal? So, in other words, what is f of -5? Absolute value of, second, 2 times -5 plus 4 minus 1. This will be absolute value of -10 plus 4 minus 1. And that is absolute value of -6 minus 1. What's absolute value of -6? 6 minus 1 is 5. So this is paired with 5. Okay, let's do f of -4. Same type thing, and you go through the thing. Let's see if we can do these maybe a little more quickly. It would be -8 plus 4 would be -4. Absolute value of -4 is 4 minus 1 is 3. So that would be 3. Do you see that? Okay. Plug in the -3 here. 2 times -3 is? -6 plus 4 is? -2. Absolute value of that would be 2. 2 minus 1 is? 2 minus 1 is 1. Okay, so that would pair with a 1. Okay? It'll come back, I hope. Come back! Okay, good. All right, -2 times 2 is? -4 plus 4 is? 0. Absolute value of 0 is? 0, and that becomes a -1, right? Okay, and then when you plug a -1 in there, okay, what's that again? -2 plus 4 is? Absolute value of 2 is? 2 minus 1 is? 1, so that pairs to be a 1. Okay, when you plug a 0 in there, what do you get? 4. Absolute value of 4 is? Minus 1 is? 3, so that becomes a 3. And then when you plug a 1 in there, 6 minus 1 is 5. Okay, so that's what that pairs to. So here's how we do our graph here. Okay. Okay. -5, 5. 1, 2, 3, 4. 1, 2, 3, 4, 5. Up 5. 1, 2, 3, 4, 5. So it's right about there. Okay. -4, 3. that would be right about there. Negative 3, 1, that would be right about there. Negative 2, negative 1, that would be down here. Negative 1, 1, that would be here, okay? And 0, 3, that would be here, and 1, 5 would be there. So here's what it looks like. Just like that. Okay? Now, here's characteristics of an absolute value function. Always a form of V. Sometimes the V may be like this or like this, but it always forms a V. Okay? This one's set off a little bit. It's dropped down 2 and over 2. No, drop down 1 and over 2. Well, there's the drop down 1, and this makes it over 2. If you factored out a 2 there, you have 2 times x plus 2. So that moves it to the left 2. You don't have to know that yet, but that's where it comes from. So that's what an absolute value function will look like. Okay? So be careful, do your evaluation, put your points in, then connect the dots. Okay? Absolute value functions are going to do that. If we had a quadratic function that sounded like some of these were the same, make sure your quadratic function is always rounded at the bottom. Absolute value is always pointed. Quadratic is, and any polynomial function is always rounded, never pointed. Okay, so there's that one. Let's see how they did it. I bet you they do it a little more organized than I did. The independent variable is x. The dependent is your y. And they do a table, and they do them out, and then you have your x-y pairs. Exactly like we did. Minus 5, 5, minus 4, 3, minus 3, 1. So you see they did all their calculation in the middle. And they drew the graph, and look how it looked. Just like ours. Maybe not quite as pretty as mine. Well, we'll leave that alone. Okay. All right. Any questions on that? What's the domain of that function? What could you put in for the x? They gave you these values, but if this was all real numbers, which, frankly, this indicates you're connecting the dots, aren't you? So what would be your domain? All real numbers. There's nothing that would prevent you from putting it in there, right? There's nothing in the denominator, nothing inside a square root. So yeah, perfectly fine. All real numbers. What's the range of this function? It would be negative 1 to infinity. It's the y values. The least y value you have is negative 1. It all goes up from there. So it's negative 1 to infinity. Perfect. Domain, negative infinity to positive infinity. All real numbers. Range, from negative 1 to infinity. Does that make sense? See it? Okay. Domain is all real numbers. Range is negative 1 to infinity. Now, here's a little hint. I hope they won't get this picky, but they might. Okay, infinity is not a number. Okay? So therefore, you put parentheses around any infinity, positive or negative. If the point is included in the function, you put a bracket there. So the minus 1 is included. Okay? Infinity, though, is not. Now, remember when we were talking about that one that was the something over x minus 2, okay? And we said the domain was everything but 2, so that went from minus infinity to 2, but not counting 2. So therefore you put the parentheses, union that with from 2, but not counting 2, because 2 can't be included to positive infinity. That would have been the domain of that function. If the 2 is not included, you put parentheses. If the negative 1 is included, you put a bracket. So that's the key. I don't know if they get that picky on the test. They might, so watch out for that. That's all of that section. And we've just got one more to go, okay? And that's 8.2c. I bet you this is applications. That's usually what it is. Okay, we'll do the slideshow from there. Introduction to functions. Oh, this is important, folks. The vertical line test, okay? The vertical line test is used to determine whether the graph is a function or not. You can have a graph of just about anything, but if you have the graph, do you have to figure out whether it's a function or not? Ha! There's an easy way. Vertical line test. Okay, remember, a given x value can have only one possible y value, right? So for any x, it can only be one y. If there were two y's, then the vertical line going through that x would hit it twice, or 3 times, or 7 times. You can't have that. So the vertical line test says a graph defines a function if any vertical line intersects the graph at no more than 1 point. Okay? That is your test to see if the graph of a function actually is a function or not. Would this be a function? It's going all over the place, but it is a function because all your vertical lines only intersect once. The key is it doesn't back up on itself. It goes up and down like crazy, but it doesn't go like this. If it went like that, not a function. Like this, yep. Every point only is intersected once. Any vertical line you put there, none of them will intersect more than once. Okay? So that does pass the vertical line test. Here's one that does not. Okay? Because this vertical line intersects only once, that vertical line intersects only once, but everything in between, and these out here don't intersect at all, but these in between are going to all intersect 1, 2, or 3 times. So that is not a function.
Is that also because the domain of 2 of the coordinates are 0?
Say that again. The domain here of this relation would be -3 to 3. That's the domain of the relation. It's not a function, though. The range would be from -4 to 4. The thing that makes it not a function is some vertical lines. In fact, many vertical lines intersect more than once. Not a function. So therefore, when x equals -2, this could be -1/2 or -3.5. Can't have 2 y's for any one x. Okay. Can't happen. Okay? That's all. Okay? Y'all feel ready for it? Did anyone of you want to take it now, or you want to wait till sometime later? Wednesday morning will be fine. I'll be here at 8 o'clock or earlier. Now, if I don't get here quite at 8, but I should, I'll be here shortly thereafter. I'll be down in my office first, so come, if I'm not in the classroom, come get me from the office, and we'll probably come up here. We may go to some other room if it's one closer to my office. That way I can go back and forth more easily. Okay? Good deal. Good deal, folks. Anyone want any more questions? Anything else?